Let's review the operation of subtraction. All right, so when we're subtracting two whole numbers, so in this example I have 9 minus 4 is equal to 5. So again, as when we work with numbers, we give names to all of them. You don't necessarily need to remember this, but in a subtraction problem, the first number is called the minuend. So M-I-N-U-E-N-D. The second number in the subtraction problem is called the subtrahend, S-U-B-T-R-A-H-E-N-D, all right, minuend and subtrahend. The one that you do need to know, though, is the answer or the result of a subtraction problem. So the 5 in this case is called the difference. The other thing that I want you to notice is when we added two numbers, the two things that we're adding together are called the addends. They're not given special names. And that connects to that commutative property of addition because the order in which we add two numbers doesn't really matter, so we just call them both addends. But the order in which you subtract two numbers absolutely does matter. 9 minus 4 is not equal to 4 minus 9. You cannot just flip the positions of the numbers around in a subtraction problem and have the same problem. So that is why they're given special numbers for who comes first and who comes second in a subtraction problem. Okay. All right, so if I want to subtract two numbers, like 958 minus 43, again, this is where place value is going to help us. So I'm going to go ahead and stack the numbers right on top of each other. So 958, leaving a little bit of space. And then the 4 is in the tens column and the 3 is in the ones column. Now, in an adding problem, if you wanted to rearrange the numbers for where they are in your adding kind of stack, you can. But on a subtraction problem, again, because the order matters, it is very important that this number stay on top and then this second number be beneath it, right? So don't start moving the numbers around. They have to stay kind of in order of how we have the problem presented. So then we're going to subtract column by column. Okay, so sometimes subtraction is considered to be a takeaway operation. So in my ones column, I have 8 take away 3. I would be left with 5. In my tens column, I have 5 take away 4. I would have 1 left. And in my hundreds column, I don't have anybody here to take away, so I'm just going to carry the 9 below the line. So 958 minus 43 would give me 915. Now, sometimes when we do a subtraction problem, when we do that kind of takeaway action, we don't have enough in a position to do our takeaway. So then we do an action called borrowing. So as our example, I've got 1,234 minus 896. So again, I'm going to stack the two numbers, one on top of each other. So 1,234 minus 896. Now in my ones column, I have 4 take away 6. Well, if I only have 4 things and I want to take 6 from it, I'm taking more than I have. So then what we're going to do is we're going to borrow from the tens column and we're going to give 10 tens to the ones column. Okay, so what we do here is we're going to put a slash through the 3 and we're going to mark it as a 2. So if I had 3 tens and I'm going to take a set of 10s away, I'm only going to have 2 tens left, and I'm going to give the tens to the ones column. Now if I already had 4 and I'm going to give it 10 more, then I would end up having 14. How we do that is we normally just hook a little 1 right here to show that this is going to be now 14. Now if I have 14 items and I want to take 6 away from it, now that is an operation that makes sense. So 14 take away 6 would leave me with 8. Now you're going to see we're actually going to have quite a few borrowing in this column, or in this problem, because now if I move to my next column, if I have 2 tens and I want to take away 9 tens, well, again, I'm going to want to take away more than what I have. So we are going to borrow from the next column. So if I have 2, and I want to borrow 1, that leaves me with 1 left over, and I'm going to hook a 1 right here next to that 2, so that ends up being a 12. Okay, so this basically means 12 tens. Right, but if I have 12 tens and I want to take away 9 tens, then in that column I would have 3 tens left. Now you could continue this game over here, right here. If I have 1 and I want to take away 8, we could borrow from right here, but also because this is kind of the last position, the other thing you can do right here is you can just read this kind of as a complete number, meaning I'm looking at these two numbers kind of together being like an 11. Now if you weren't seeing that, it's not a big deal. You could just do this borrowing game again. This 1 becomes a 0, right, if I do the takeaway, and I'm going to hook 1 right there. But again, when I hook that 1 right there, that's the 11 that I was seeing. All right, in any case, if I have 11 and I want to take away 8, I'm going to be left with 3. All right, so 1,234 minus 896 gives me 338. Now, sometimes the whole process of borrowing gets a little confusing, so I just want to show quickly a different way to think about this, relying on that expanded form and really just kind of drawing upon our numbers and what's kind of going on when we do these various operations. So the 1,234 can be thought of in expanded form as 1,000 plus 200 plus 30 plus 4. Now ultimately I want to take away 896. So I want to take away 800, I want to take away 90, and I want to take away 6. Now, the nice thing about expanded form is that you can maybe think about the numbers kind of pairing with numbers in different columns. And what I mean by that is when I look at this, I kind of see more, if I have 1,000 and I want to take away 800, I would have 200 left. Okay, so I'm not grouping the 800 in my hundreds column. I'm kind of thinking about it playing against like the bigger column, right? If I have $1,000 and I spend 800, I would have $200 left. So I've kind of already accounted for these two numbers in this difference. So now looking at what I have left over, I'm as opposed to the 90 interacting with the 30, because again I'm trying to take away more than what I have. I'm going to think about that 90 interacting with the 200. So if I have $200 and I want to take $90 away from it, then I would end up with $110. So I'm just going to record that down here, and again I've kind of accounted for those two numbers. So then for what's left, and you could do this a bunch of different ways. You could either think about this as 30 take away 6, or maybe I just want to group these two numbers together and think about it as being 34 take away 6. So if I have $34 and I want to take away $6, I would end up with $28. All right, again, there's some flexibility for how you want to do this. The important idea is that you need to be able to kind of see and understand how these numbers are interacting against each other. So when I want to go put these pieces together, then I'm going to again think about my positions. So in my hundreds columns, I have the 2 and the 1. So if I put those guys together, I'm going to have 3 in the hundred spot. In my tens spot, I got no tens there, but I got 1 there and 2 there. So that would give me 3 in my tens position. And then in my ones position, I've got nothing there, and I've got 8 there. So then if I put my 1 spot stuff together, I would have an 8 in there. So I get the same answer, but a slightly different way of getting there.